Hi, this is Kate, and we're doing operations on fractions. I know fractions can inspire some fear and uncertainty, and we wonder why we need them at all. Here's a story about why fractions are required, even to solve simple problems. Alice and Claire frequently visit Grandma. Grandma likes to bake cookies, and today Alice and Claire discover Grandma has 4 cookies in her jar. "Oh, Grandma, may we eat these cookies?" says Claire. "Of course you may, dears, if you share them equally." So Alice and Claire enjoy 2 cookies each. Next week, Alice and Claire bring along their friend Emma. Once again, they find 4 cookies in Grandma's jar. "Oh, Grandma, may we eat these cookies?" says Claire. "Of course you may, dears, but the 3 of you must share them equally." The girls think and think, and decide that at least it's fair if they have 1 cookie each. But what to do with the remaining cookie? If they want to share the 4 cookies equally, they have to use fractions. There's no way around it. They had 4 cookies and had to split them 3 equal ways. So each girl ended up eating 4/3 of a cookie. The 1 cookie was 3/3 and they got an additional 1/3. We might also call 4/3 1 and 1/3. So fractions have 2 parts. How many parts we're dividing the thing into, and then how many of the parts we want to include in our number. If we're talking about 2 parts of 3, we say that's 2/3. Once we allow fractions into our world of numbers, we need ways to work with them. What if we want to bring 2 fractions together, like 2/6 and 3/6? What do we get if we add 2/6 of a rectangle to 3/6 of a rectangle? Altogether, we get 5/6 of the rectangle. That was kind of obvious because we were adding things of the same size. But what if we want to add 3/8 and 1/2? This is more difficult because we're no longer adding the same size things. We can't really say we end up with 4 of something because they're not the same kind of thing. Let's maybe take a guess first. What do you think the answer will be? Here's a hint. Instead of halves, we could divvy up that second rectangle into fourths, multiplying both the number of total regions and the number of gray regions by 4, but not really changing the fact that 1/2 of the rectangle is shaded. Now we can think of it as adding 3/8 and 4/8. Now what do you think the sum will be? The sum will be 7/8. When we subtract objects, we seek to take them away. What if we want to start with 3/4 of a rectangle and take away 2/5 of it? First, take a guess at what you think the difference will be. We have the same kind of problem as before. We're not taking away the same size things. First, we must turn them into the same size things. If we divvy up the first rectangle into fifths by multiplying the number of regions by 5, and divvy the second rectangle into fourths, multiplying the number of regions by 4, we've turned both rectangles into 20ths. Now can you tell how many will be left if we take away 8/20ths from 15/20ths? The difference is 7/20ths. To summarize, if we want to add or subtract fractions, we need them to have the same denominator, that's the bottom, so we're bringing together or taking away the same kinds of things. If we turn them into the same kinds of things by multiplying the tops and the bottoms of each in a way that will make them match, then we can combine the same kinds of things, like 20ths and 20ths. We hold on to the bottom, what kinds of things we're talking about, and we do our adding or subtracting to the number of things on the top, that's called the numerator. Next, we'll investigate multiplying fractions. It's helpful to model multiplication using the area of a rectangle. For example, if I want to multiply 6 by 3, I can picture a rectangle with one side that measures 6 and the other side that measures 3. This results in 18 squares and gives us a picture of why 6 times 3 is 18. We can picture multiplying fractions with the same technique. If we want to multiply 1/2 times something, we'll consider half the side of a rectangle. Say we want to multiply the 1/2 by 1/3. We consider 1/3 the other side of the rectangle. Now how much of the rectangle do we end up with in the section where 1/2 is multiplied by 1/3? The result is 1/6 of the rectangle. Notice the tops of the fractions. 1 times 1 results in 1, and the bottom. 2 times 3 is 6. Once we picture these products as the area of a rectangle, we can develop a shortcut and see why it works. Let's take 5/6 of the rectangle and multiply it by 2/3. Now the total number of regions is 6 times 3, or 18. And the overlap of the parts we're interested in is 5 times 2, or 10. The shortcut for multiplying fractions is multiply the tops and multiply the bottoms. You try one. What is 3/5 times 7/10? The product is 21/50. You might have noticed that we could have expressed 10/18 of the rectangle in terms of ninths instead of 18ths. If we divvy the rectangle into ninths instead, the product is 5 regions out of 9 instead of 10 out of 18. While multiplying 5/6 and 2/3, we may have noticed that 2/6 reduces to 1/3 and simplified the factors before multiplying. Try this shortcut for yourself. See if you can reduce any fractions before multiplying. Make your best guess. Here's a hint. 15/5 is the same as 3 groups of 1. And 7/14 is the same as 1/2. Now what do you think the product is? You can change your answer or select the same answer. The product is 3/2. What if we want to multiply a fraction by a whole number? This is not as difficult as it seems. If we remember that we can also express 8 as 8 over 1. 8 things is the same as 8 groups of 1 thing. What is the product? You may have noticed that 8/16 is the same as 1/2. The product is 15/2. To understand dividing by a fraction, we're going to go back to cookies. Division is separating objects into equal-sized groups. If I start with 6 cookies and divide them into groups of 3 cookies each, I end up with 2 groups. If I take 6 cookies and divide them into groups of 2, I end up with 3 groups. If I take 6 cookies and divide them into groups of 1, I end up with 6 groups. But what if I take 6 cookies and divide them into groups of half a cookie each? How many groups do I end up with? The answer is 12 groups. So 6 divided by 1/2 is the same thing as 6 times 2. What do you think we get if we take 6 and divide it by 1/4? The answer is 24. We can think of quarter cookies, of course, or we can use a shortcut. 6 divided by 1/4 is the same thing as 6 times 4. So 6 divided by 1/2 is the same as 6 times 2. 6 divided by 1/4 is the same as 6 times 4. What do you think about 6 divided by 3/4? Take your best guess. Here's a hint. If we break the 6 cookies into groups of 3/4 of a cookie. Can you tell how many groups result? Answer the question now. You can change your answer or keep the same answer. The result is 8 groups. The shortcut would be, instead of thinking about dividing by 3/4, to multiply 6 by 4/3. This is Kate, and you've been learning about operations on fractions.